The solar system consists of the sun and the planets going around the sun in different orbits. I'll show three such orbits. There is the nucleus in the center and all the electrons revolve around the nucleus. I have shown some 5 electrons. They keep on. Hello, welcome to Guidancee Education Channel. In this video, we are continuing Class 11 Chemistry, second chapter, Structure of Atom. Now, we will see the topics that are discussed in this video. The topics discussed are alpha particle scattering experiment, discovery of nucleus, planetary model of atom, comparison of atomic model with solar system, drawbacks of Rutherford's model of atom, that is planetary model. This video will help you understand the basic concepts regarding the structure of the atom. The experiment, observations and inferences are all very important from examination point of view. So watch the video completely, do not skip it. And if you think it is useful, like the video, share the video and also leave your comments in the comment box below. If you have not yet subscribed my channel, do subscribe it now and also press the bell button so as to get intimated as soon as videos are posted. Thank you very much. I have also added a few questions as usual in the description box. Do not forget to see that. Okay, let us see the video. Now we will see Rutherford's alpha particle scattering experiment, otherwise called gold foil experiment. This experiment resulted in the discovery of nucleus. Based on the findings of this experiment, he proposed an atomic model which is called Rutherford's atomic model or nuclear model or planetary model of atom. This is the diagrammatic representation of the experimental setup. This is the lead block which contains the radioactive material which is the source of alpha particles. Alpha particles are nothing but helium ions. They are heavier than hydrogen ions. This is a slit. Beam of alpha particles are produced from the source of alpha particles. This is thin gold foil. It is so thin that it contains only a few layers of atom. The slit allows only a beam of alpha particles to pass through it and strike the gold foil. This is a thin film coated with zinc sulfide which can glow in the presence of charged particles. When the beam of alpha particles pass through the slit and strike the gold foil, it undergoes scattering and spots of glow develop on the thin film. Majority of the alpha particles move on without deviation. A number of alpha particles got scattered at an angle less than 90 degrees. A very small number bounced back at an angle greater than 90 degrees to the direction of flow of these alpha particles. The beam of alpha particles and their scattering path is not visible. What is visible is only the points of glow developed on the thin film coated with zinc sulfide. We will note this as observations. I will make the scattering more clear by using one more diagram. This is the path of the alpha particles. A very large number, that is majority of the alpha particles, move on without deviation. A small number of them deviate at an angle less than 90 degrees to the direction of motion of the incident alpha particles. A very small number bounce back. That is what you see here. So he studied this observation and explained that majority passed on without deviation because the major portion of the atom was empty or vacant. That is the explanation for the first observation. Explanation for second observation. A certain number get deviated. It suggests the presence of positive body in the atom. A very small number bounced back. It suggests that the positive body is small and heavy. This positive body which is heavy he called nucleus. From this he gave the atomic model. Based on the findings of his experiment, he applied his findings on the structure of the atom. I have given here a picture of the application of the results of the alpha particle scattering experiment as suggested by Rutherford. He suggested that the nucleus, which was positively charged and very small, occupied the center of the atom, with the electrons revolving around the nucleus. The beam of alpha particles, which passed through this vacant space, passed on without deviation, and those rays which came near this positively charged body, which he called nucleus, those rays got deviated. The alpha particle rays which hit the nucleus, which is massive when compared with the alpha particles, the alpha particle bounced back. This is how he explained this single atom. Now, for a group of atoms, say in 2 or 3 layers, the alpha rays suffered deviation when it came close to the nucleus of an atom. And when it passed through the empty spaces, it went on without deviation. And when it hit the nucleus of an atom, it bounced back. I hope you were able to understand the scattering experiment more clearly with the help of these diagrams. So, according to his model, the atom consists of the central nucleus, electrons revolving around it. That is, electrons are not stationary. The centrifugal force due to the circular motion of the electrons helped the electrons to remain in their path and not collapse with the nucleus. So this model resembled the planetary system or the solar system, sun similar to nucleus and electrons similar to planets. Just as the planets go round the sun, the electrons go round the nucleus. That is why his model is called nuclear model or planetary model. But later on, the nuclear model suggested by Rutherford was found to have certain drawbacks. We will see the drawbacks. Now let us see the drawbacks of Rutherford atomic model. As already suggested, the Rutherford atomic model is called planetary model because it is compared with the solar system. The solar system consists of the sun and the planets going around the sun in different orbits. I'll show 3 such orbits with their planets. I have shown only one revolution for each planet, but they always revolve around the sun. According to Rutherford's atomic model, there is the nucleus in the center and all the electrons revolve around the nucleus. I have shown some 5 electrons. They keep on revolving. They are going around the nucleus simultaneously and not one after another. I have shown it like this only for you to understand. So this is the nucleus. It is positively charged. These are the electrons. They are negatively charged. The sun or the planets are non-charged objects. By applying principles of classical mechanics, they have shown that these planets move in definite or well-defined orbits. The planetary orbits have been calculated using the principles in classical mechanics. The force which keeps these planets in their path is the universal gravitational force, and it is equal to gravitational force Fg is equal to universal gravitational constant G into m1 m2 by r square. m1 and m2 are the interacting masses here, mass of the sun and planet. Whichever planet we are studying, we have to take the mass of that planet. R is the distance between the planet that is considered and the sun. So this is the formula for gravitational force which keeps these planets in its path. By applying principles in classical mechanics, the planetary orbits have been calculated and the calculations agree with the experimental results. As Rutherford's atomic model is compared to solar system, the principles of classical mechanics was applied to explain the atomic structure. Just as there is gravitational force between the planets and the sun, in the case of atomic structure, there is also a force which is the Coulombic force because the nucleus and the electrons are charged, given by the formula K into Q1 Q2 by R square. Q1 and Q2 are the interacting charges, that is the nucleus and the electrons, and R is the distance between the nucleus and the electron. This formula is similar to the formula for gravitational force. As the atomic structure is compared to solar system, the electrons, which are like the planets, go round the nucleus in orbits. Any object which is moving in orbit get accelerated even if they are moving with uniform velocity. Since the direction is changing, they naturally get accelerated. The planets as well as the sun are non-charged objects, but in this case the electrons as well as the nucleus are charged objects. According to Maxwell's electromagnetic theory, a charged object in orbit will radiate energy. This energy comes from the electron itself by virtue of its motion in the orbit. So, the object is losing energy. When it loses energy, its orbit starts shrinking. It shrinks and continues to shrink and finally collide with the nucleus. In such a condition, the atom will become unstable. But what is our observation? Atoms are stable. So one drawback of Rutherford's atomic model is that it does not explain stability of atom. That is, when principles of classical mechanics and Maxwell's electromagnetic theory is applied, this atomic model could not explain the stability of atoms. Another drawback of Rutherford's atomic model is that it does not mention electron configuration, that is, how electrons are distributed in the orbit. Another thing is, it does not speak about the energy of electron. These shortcomings were later on explained by Bohr. His model came to be known as Bohr model. We will discuss that only in the next video. Anyway, though Rutherford's atomic model had a few defects as is mentioned here. His model suggested that electrons are moving, nucleus is in the center, electrons are moving around, there is lot of vacant space in the atom. All these points are accepted. I would like to mention one more point before we wind up this topic. That is, it could not explain the stability of the atom because he said that electrons are not stationary, it is moving around the nucleus. For argument's sake, if we consider that the electrons are stationary and not moving, even then also it cannot explain the stability of the atom because if they were stationary, the electrostatic force of attraction between the nucleus and the electron would attract the electron towards the nucleus and cause the electron to collide with the nucleus and cause instability of the atom. So, whether we consider electrons are moving or stationary, it cannot explain the stability of the atom. That point also is important. So we have discussed three important shortcomings of Rutherford's model. Okay. I hope this video was of great use to you. If it was useful, like the video, share the video, and also leave your comments in the comment box below. If you have any doubts, you can also post those doubts in the comment box. Your comments and subscriptions are of great motivation for me. Thank you very much. We will meet in the next video with another important topic. Till then, bye.